Hello guys, today in this video we will see how to find the intersection point of two linked lists. What is mean by the intersection point? In the given two linked list, if both these linked lists point to a common sublist, then the first node of that sublist is the intersection point. Let us understand with this example. Here, let's say this is list 1 and this is list 2. Now both of these lists have this common sublist. So the first element of the sublist is 10. So it will be the intersection point in this example. Let us see more examples and find the intersection point. Okay, now see these examples and find the intersection point here. So in this example we have two lists and we have this sublist 6 and 7, so the intersection point was 6. And in this example we have this sublist 50, 10 and minus 1, and the intersection point was 50. And let's see this example. In this example both these list 1 and list 2 doesn't share any common sublist. So in this case simply we don't have any intersection point. Okay, now let's write the step-by-step approach of finding the intersection point with this example. At first we will start both our list 1 and list 2 references at the head node, and we will in each step we will go through these two lists until the intersection point is found. How can we know that the intersection point is found? Well, the reference of list 1 and list 2 were same. We found, that means that we found the intersection point. Let's write this condition. List 1 node double equals to list 2 node. That means that we found the intersection point. So we need to iterate through until the intersection point is found. So we'll just change this condition here. And make it a while loop. So this loop will run until this intersection point is found. That was we mean to do. So by the iteration we mean we need to increment the reference of list 1 and list 2 in each iteration. So we do it by list 1 node equals to list 1 node dot next. Same with the list 2 as well. List 2 node dot next. Okay, and at the end we will get into this intersection point. So we will just return this intersection point, whether it can be found in list 1 node and list 2 node as well. We can either return this list 1 node and list 2 node. That's our choice. So yeah, we came up with the core logic. Let's see this core logic is work with these three examples as well. Let's see. Okay, let's analyze with this example. Initially our L1 will start with 1 and L2 will start with 4. After the iteration our L1 will be at 2, our L2 will be at 6. Our 6 is the intersection point. So now let's just check this condition. 2 not equals to 6, this will be true, and this will go for another iteration. We are expecting that we don't want this kind of behavior. what we expecting is we need to break the loop and return this list1 node. This is not happening here. Why? Because the list1 is not equals to list2 in comparison with the size. The list1 size is 5 and the list2 size is just 3. In our previous example, both our lists were size of 6. So our code is not working when both the list is of not same size. So let's resolve it now. Let me provide a clear solution for this problem. Our primary problem is with size. We have different sizes for these two lists. What we can do is we can delete these extra nodes so that we can make these two lists have the same size. Another approach was starting this L1 iteration from the 3 and L2 iteration from the 4. I think this would be the best approach. So how can we do that? For that, we need to find the difference between these two lists. So the difference between these two lists is L1 dot size minus L2 dot size. So after finding the difference, we need to iterate this list1 two times and get our L1 pointer to the 3. We can do this with an while loop like this way. I have quickly written this while loop. What this while loop will do is it will iterate until we get the list1 node to the 3. So let's see, this code will also work for this example. Let's see here. So our list1 size is of 5 and list2 is 6 here. So our code will not work here. Since we assumed that list1 is always greater than list2, we wrote this code. In this case, it's not the true. List2 is greater. So we will just modify this while loop in order to support these cases as well. So let me write this. So let's find the difference value for this case. The L1 size is 5 and the L2 size is 6. So our difference will be of -1. For this case, our difference is 2, which is a positive value, and this is a negative value. Why this happened? If our list1 have the greater size, that means we will definitely get the positive value in difference. If our list2 is greater, then our difference will be definitely a negative value. So we can write an if condition that if a difference is greater than 0, then we will execute this code. We will increment the list1 node. If that is not the case, that means list2 is greater, so we will increment list2 node. So let me modify this while loop and show you. So I have erased this previous while loop that will not support list2 as a greater size. So let's write this new condition. So our while loop will iterate while the difference is not equals to 0, and let's write the condition if the list1 is greater. So if the difference is greater than 0, that means the list1 is highest. We need to iterate the list1 node equals to list1 node dot next. since the difference is a positive value, we need to decrease it until we get it 0. So if that is not the case, that means the list 2 value is greater. So we need to iterate this list 2. Since the difference is at negative values, so we need to increase it to make it up to 0. So this code will run with these two cases. Let's see if this code will also run with this case. With this case, what will happen is the list 1 size is 3 and the list 2 size is 3. So the difference is 0. So this while loop will not be executed and directly come to this while loop, and this while loop will execute until the end of both the lists. So the end of the both list will be null. So when list 1 and list 2 node will become null, that means that this while loop will break, since null not equals to null was false, and will return this null value. So our code will also execute for this case also, since we also need to return null if none of this intersection node was found. Okay, let's try to run this code. So this list 1 will represent the list 1 and this list 2 reference will represent the list 2. At the end, these are the both the lists. Our both lists will intersect at point 4, and we're just calling this find intersection point function by providing the parameters list 1 node and list 2 head node. Let me run this and show you how this all work. Yeah, I have printed this list 1 and list 2 to show you guys, and this 4 is the intersection point, and we call this find intersection point method, so that return this 4 node as expected. As you can see, I have also added the size of ll function, which returns the size of a linked list, so that we will use in finding the difference. So this is all the same code that we previously talked about. So that is it for now. Let's run this code with different test cases and let me know if any test cases was failed. Thank you for watching this video. I hope you enjoyed. Thanks. Bye.